Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saifuddin Khan bin Nazaruddin. So I'm from Group 1. We are presenting about Experiment 1 Marcet boiler. So my other group members are Aina Alia binti Abdullah, Ahmad Diauddin Arif bin Shihabuddin Arif, Darshana anak perempuan Hari Krishnan, and Divya Lashmi anak perempuan Puendran. So now I am going to tell you about the abstract of this experiment. So during the course of this experiment, a Marcet boiler was used to determine the temperature of a body when being heated or cooled, as well as observing the relationship between saturated pressure and temperature of water in the range of 0 to 14 bar as indicated by the gauge. The relationship between the temperature and pressure is one that directly proportional to one another, meaning that both will rise or fall if the other rises or falls. We assume that the temperature gradient was even throughout the surface of the boiler and the stream temperature of the outside surface was the same. In theory, values given in the steam table should be same or similar as our recorded values. In the case that is not, then it will mean that there is an error in our experiment. Next, moving to the introduction, this experiment was carried out in the precious and timely manner and follow the procedure, which was to fill water into the Marcet boiler until the water is occupied half of the boiler. After turning on the boiler, it is as important to note that all the air must be removed from the boiler, so you leave the valve open in the beginning of the experiment. Once the temperature reaches 100 Celsius, the valve will be closed after some steam is released. The recorded temperature reached 14 bars. Next is the objective of this experiment. So the objective is to study the relationship between pressure and temperature for saturated stream. That's all from me. Thank you.
Hi, my name is Darshana Harikrishnan, and today I will be walking you guys through the theory behind the Marcet boiler experiment. Thermodynamic properties of a pure substance could be determined by two of the following characteristics: temperature, pressure, enthalpy, entropy, volume, and etc. Data characteristics could be obtained either from experiments or equations or using certain. Among two thermodynamic properties that easily measured are temperature and pressure. Marcet boiler has been developed for investigating the relationship between the pressure and temperature of saturated steam in equilibrium with water at all pressure between atmospheric pressure and 10 bars. The measure value of the slope of the graph dt over dp sat obtained from the practical results can be compared with corresponding values calculated from the data in steam tables. Clausius, the German physicist and one of the founders of thermodynamics, was instrumental in deriving the relevant Clapeyron relationship. The equation can be seen below, which is the difference in temperature over difference in pressure in saturated state equals to temperature times volume of water minus volume of steam over enthalpy of water minus enthalpy of steam. If the value of volume of steam is much larger than volume of liquid, then your dt dp sat equals to T times Vg over HFG. HFG being enthalpy of water minus enthalpy of steam. Thank you.
Hi, Assalamualaikum and good day. My name is Aina Alia binti Abdullah and I will present for the methodology of our first experiment in thermodynamics lab, which is the Marcet boiler. So, before I move on to the methodology, let me introduce the apparatus used to conduct this experiment, which is the Marcet boiler itself. So this Marcet boiler includes the switch box and the cylindrical boiler made of thermically insulated steel and also electrical resistance for water heating and evaporation. So as you can see from the picture, there are 8 important parts in this Marcet boiler, which is the number 1 that shows the safety valve, and then we have number 2 that points on the boiler with insulating jacket that will prevent the heat released easily to the surrounding. And then next we have number 3, which is the manometer or the pressure gauge for the readout of the relative pressure inside the boiler. And then we also have number 4, which is the switch box, which contains the master switch, the heater switch, and also temperature gauge that will give the readout of the temperature inside the boiler. And then after that, we also have drain valve, which is the number 5 to release all the water inside the boiler. And then number 6 shows the heater inside the boiler, which we'll use to heat the water. And then we also have number 7, or we call overflow valve, used to release excess water, which also shows that the boiler is full. And then last but not least, we have number 8, which is the temperature sensor that will help to read the temperature inside the boiler. And actually there is another part, which is the filler plug used to fill in the water, which is placed on top of the Marcet boiler. So now as we're done with the introduction on the apparatus, so let's move straight to the methodology of the experiment. So first thing first, the filler plug is open to fill the boiler with water, and then the overflow valve is ensured to be open to let the excess water flow out, which shows the boiler is full, and then the filler plug is closed. Next, the water is being heated while keeping the overflow valve opened, and then when the temperature reached about 97 degrees Celsius to 100 degrees Celsius, the overflow valve is closed. And then the increase in temperature for each pressure is recorded from 0.5 bar until the pressure reaches 5 bars, and then after that the heating process is switched off, and then the decrease in temperature is also recorded for each decrement of 0.5 bar. So that is all from me from methodology part. Now I pass this presentation to the next presenter to present about the result and discussion. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Dedin Arif, and I will be presenting about results and discussion. As we can see in the table consists of a few elements that we either measure or we need to calculate. Here we have gauge pressure, which is in bar, absolute pressure, which is also in bar, increasing temperature, decreasing temperature, and mean temperature, which is in Celsius. Next, we have measured slope and calculated slope, which we will show how to calculate later. And last but not least, percentage difference. For the mean temperature, the way to calculate it is by adding the increasing temperature and decreasing temperature. Later, we will divide the sum by 2, and the results are as follows. Next is to calculate the measured slope. dP is the difference in pressure, which we can calculate by subtracting current pressure to subtracting previous pressure from current pressure. The same goes for dt, which is difference in mean temperature, which we will need to subtract previous mean temperature from the current mean temperature. We will later need to divide the dt with the dp to obtain the measured slope, as we can see in this table. Next would be the calculated slope. For the calculated slope, we have a specific formula that we have been given to use, as shown in the slide, which is Vf is the volume of water, Vg is the volume of steam, Hf is the enthalpy of water, and Hg is the enthalpy of steam. The T stated in the formula is the mean temperature for each absolute pressure increment shown in the table earlier. This is where we obtain the value for Vg and Hfg for each pressure n bar. And the result is as shown. Next, we will move on to the graph. This is the graph for absolute pressure versus decreasing temperature. And this is the graph for absolute pressure versus increasing temperature. Next on for discussion. Discuss your observations during the experimental conducted. Discuss also the plotted graph and indicate the relationship between temperature and pressure of steam. Both the graphs for increasing and decreasing temperature are shown to be increasing as both pressure and temperature increases. However, theoretically, it is supposed to be directly proportional, but the graph we have seen earlier showed it is not exactly directly proportional. This can be explained by errors happening during the experiment. For the relationship between pressure and temperature, when the water in the boiler is heated up, molecules starts to gain heat and move faster. And when this happens, as liquid gains heat energy, we will know it will later turn into gas. As steam is not allowed to exit, the pressure will increase. This is because of the enclosed space where the water is being boiled. Thus, as the steam is not allowed to exit, the pressure will increase, thus causing temperature to rise. Calculated and measured slope is compared by calculating its difference in percentage, which is also in the table earlier. Here, in percent. As the results were shown earlier, differences from negative 16% to 49% can be seen. For the positive percentage error, experimental yield is smaller than theoretical yield, and for negative percentage error, vice versa. Experimental yield is larger than theoretical yield. Errors mentioned earlier is consists of these three, which is measurement, reading accuracy, room temperature and pressure, and error in calculations of the data obtained. That I thank you.
Last but not least, I am Divya Lakshmi will be presenting on the conclusion of experiment 1, which is Marcet boiler. In the table of result, it shows that as the absolute pressure increases, the mean temperature increases as well. In both increasing temperature and decreasing temperature graph, both slopes are not in directly proportional manner but in increasing function. There are some errors that can be avoided while conducting the experiment other than stated above, which is, firstly, repeating the experiment and taking the average value. For an example, we can repeat the experiment twice or thrice for both increasing temperature and decreasing temperature to get an average value which will be more accurate. Secondly, conduction and convection heat transfer depends on the thermal properties of the fluid. This is understandable because it affects the velocity profile that affect the rate of energy transfer in the boiler wall and drum. Thus, it is recommended to use insulated Marcet boiler which can reduce the heat loss to the surrounding. Thus, we can reduce the percentage in difference and it will be more accurate. lastly, these are the reference our group used in completing our lab report. That's all from our group. Thank you.